Hello, everyone. Thank you for coming to this talk today. Today, I'll be talking about the cost of bad code and pipelines. Now, before we get into this, I wanted to just give a quick intro to who I am. My name is Austin Akers. I'm currently a software engineer at Microsoft. I'm also a co-organizer of Free Code Camp Dallas. And outside of like my free time of, just programming all the time, I love doing Muay Thai. And I also am a b-boy. I like to break, or as a lot of people may know it as, breakdancing. So I do a lot of breakdancing. Now, jumping into this talk, just wanted to give you a quick overview of what I'll be discussing. There's, three parts to this. The first part being, we'll be discussing on how to identify bad code and bad pipelines. And by bad pipelines, I mean CI/CD pipelines. The second thing we'll go over is the cost of both, bad code and also bad pipelines. So when I talk about cost, I'm not talking about just financial. We'll then go over productivity and even the end user experience as well. And last but not least, after going over both of those, we'll then end it with actions to transform the current state of where you're at. Okay, so let's do this. Now, how to identify bad code in pipelines. Now, going through, the wonderful world of search engines, I was trying to find like the actual definition of what bad code is, and I couldn't truly find it. But instead of actually, because there's just so many different, there's like so many different definitions and what people think bad code is. So instead of actually giving a definition, what I decided to do was highlight the characteristics of just a few characteristics of what bad code is, or may be. The first one being it's hard to read and understand. The next one being it's not extensible. So if you were to build out a function, being able to build off of that or build out some sort of functionality in a sense, being able to build on that and build out, let's say, a feature or whatnot, it becomes very difficult. And last but not least, the changes cause side effects. Now, when we're talking about the sense of bad code, let's say you make a change in one part of your application, right? And unfortunately, it breaks something else completely separate, or you would think so, on a different part of your application. So changes within bad code can cause side effects in your application. Now, jumping over to bad CI/CD pipelines, the characteristics of a bad pipeline would be slow release cycles. Another one being high financial cost. Means it's expensive to run builds or deploy things. And last but not least, it increases the friction in collaboration. And what I mean by friction, increased friction in collaboration, we talk about the CI part, right? The continuous integration. In CI/CD, there's continuous integration to continuous deployment, right? Continuous development or continuous deployment. But the continuous integration part enables a stronger collaboration between developers, meaning like, bugs and bugs are found and fixed a lot earlier and faster in the development process. But having a bad pipeline, that makes it very difficult to do so. Now that I've talked about the characteristics and of bad code, why don't I just go over an example? Now, for this specifically, wanted to give an example of some bad code I wrote about roughly about 4 or 5 years ago. Okay. Now, as you can see here, let me go ahead and get my laser pointer. Now, as you can see here, this is some code I wrote about 4 or 5 years ago, and there's a lot of things that could have been improved with this. Now, granted, if you haven't been developing for about 4 to 5 years, no worries. The best part about being a developer and growing is that when you look back, you get to see a lot of the improvements that you've done, and also seeing a lot of the code that you wrote and just reflect upon that. But looking at this code, there's a few things specifically wrong with this on why this right here is bad code. Well, first off, if we take a look into like this for loop right here, the naming that we have on our variables isn't very descriptive. So we look at ob_tree. All I know is, well, what exactly is ob? All I know is has something to do with like a tree, or even sp_tree. What's the sp part, right? So stuff like this, it's very difficult to truly understand what exactly this is and what it's doing. And another thing as well is that there's a lot of magic numbers. Now, if we jump down here to ob_tree.position.set, now first off, we don't even know like what exactly are we setting, but we look at all these numbers here, right? We have something like 96 times I, and like all this, like 96 times I divided by 8. And we don't know what 96 represents at all. Like, why are we dividing by 8? What specifically does all this mean, right? And so there's a lot of magic numbers within this code snippet. And last but not least, we're not following the default JS naming convention, right? Now, ob_tree, if I'm not mistaken, that means object, right? But is this how we define objects within JavaScript? Or, we look at var. Well, nowadays we're using let and const. Now, if you're not familiar with, let versus const versus, var, I highly recommend you search it. There's a lot of amazing articles out there. I think even Free Code Camp had a really great article about this. But we're not following a lot of the, default JS naming conventions on the way we're declaring variables and or even like naming them as well. So now that we've given an example of what bad code might be, let's take a look at an example of what exactly a bad pipeline might be. Now, for this specifically, I wasn't able to find a bad pipeline, that'll allow us to, that we can actually dive into and take a look at. But what I wanted to do instead is try to highlight on like at least an example of what a bad pipeline might look like. Now, first one being running tasks that can be ran once. And what do I mean by that? Well, a good example would be images, right? Having your images go through your build process every single time as soon as you push something. That's actually something I've done before early on when I started getting into building out CI/CD pipelines. But something like that could make a huge difference in your build time. So running tasks that can be ran once, like you only need to like run that specifically. You only need to build your images if you ever add a different image, or when you decide to remove something, or you interchange a certain image, right? So that right there, running tasks that can be ran once or not as often as what we may think. The next one being tests are hard to reproduce locally. So if something fails, like your integration test, if they end up failing on your pipeline, and you're like, oh man, like, all right, well, something failed. Let me take a look at this locally, right? If they're hard to reproduce locally, then that becomes a huge problem. And last but not least, long CI/CD build times. And you'll see this a couple times throughout this entire presentation, but this is a very important one as well. Now that we've talked about the characteristics and given examples, let's look at the cost of bad code and pipelines. Now, in this specific section, we'll be discussing the negative impact, well, how bad code itself and bad CI/CD pipelines have negative impacts on our productivity, the financial aspect of things, and last but not least, our end user experience. And you'll come to realize that in our end user experience, it's not just our customers, it can also be us ourselves. Let's dive into productivity. Now, specifically for bad code, we're looking at the first bullet point, increases task time estimates. And what do I mean by that? Well, what I mean by that is as you start scaling out and the code that you have isn't properly maintained, the complexity of your code base increases substantially. So when you start making very small changes, the time estimate to even make those small changes increase exponentially. Next up is that it impedes newer development, so building out new features, which brings me to my last point. We'll look at increased technical debt because you're focused more on maintenance and technical debt. You don't have the time to focus on a lot of the newer development that you may want to do within your application. Now, jumping over to a bad pipeline, right? Well, for one, long CI/CD build time is it can be very frustrating in regards to productivity. So having to sit there and wait for, let's say, sometimes 40 minutes to even an hour when something could take, let's say, when a build could actually take, if it was streamlined, 15 to 30 minutes. So long CI/CD build times affects developer productivity, especially in regards to be able to effectively test and push changes and get those prepped for production. Next up, point 2 is inconsistent integration testing. So having inconsistent integration testing affects productivity because, again, as we referenced before, it's very difficult to be productive when things are, failing and succeeding, and there's no consistency in regards to the integrity of how things are ran. And last but not least, no notification triggers in the pipeline. Now, that was pretty specific, but I can tell you a personal story. So when I worked at a company, one thing we did not have were actual notification triggers. So something I'd always have to do, and I was just on a laptop, I'd end up having to always either alt tab back, or better yet, like divvy up half my screen to the to like see, like, to check on the pipeline, and the other half and trying to do work if possible, but not having ways to alert you when something fails or succeeds can really affect the overall productivity of a developer. Now, jumping into this, let's go ahead and jump back and take a look into the average developer work week. How does bad code itself affect the average developer? Well, Stripe did a study, and in fact, they released They released a study. It's called the Developer Coefficient. And this was released in September of 2018, and they surveyed a lot of developers globally, right? And globally, the average developer works 41.1 hours a week. Now, I understand some people work more, some people work less, all right? But the average developer globally works 41.1 hours a week. And out of those 41.1 hours, 13.5 hours is spent working on technical debt. And that's quite a bit. And as we jump to our last point and we take a look, 3.8 of those hours is spent on bad code. Now, if we shift over to the pie chart over here to the right, we can see that 13.5 hours is actually 33% of our work week. And that's spent on technical debt. And that 3.8 hours is you're spending on bad code. That's 9% of our work week as well. Now, collectively, it's safe to say that the average developer in their work week spends roughly 42% of their time not having to work on bad code, but also the results and the effects of a bad code itself, which is technical debt. And then I also have the 58%, which is like other. That could be meetings, features, who knows, memes. All right. Going on dev Twitter. Oh, that's also very interesting, but that's a story for a different day. Next up, let's look at the financial impacts. Well, the financial impacts of bad code at maintenance cost increases over time. And in fact, a study conducted by IBM found that the cost of a bug found in production can cost up to 100 times more to fix than if it was found in the planning phase of the process. So at maintenance costs can increase over time, right? Bad code, can cause, as I said, causes technical debt, and that right there can be very, very costly. And the next one, high talent turnover. Now, I can attest to this personally. I actually worked at a company, just some years back, worked at a company and got hired on, felt really, interesting. But what ended up happening is that I finally, cloned the repo, cloned the entire code base, and was looking at it locally, and the code base was rough. And I kid you not, when I mean by the end of the week, I was like, this is just too much. I'll be spending 80 to 90% of my time on maintenance, and hopefully, if even 10%, maybe 20% if I'm lucky, on building out new features. And so by the end of the first week, I was looking for a different job. So the unfortunate cost of bad code is that you end up having a high talent turnover, and even attracting new talent as well. Now, if we take a look at this, SHRM, the Society for Human Resource Management, estimates the average replacement cost of a salaried employee to be roughly 6 to 9 months of that individual's salary. So, for example, if we have a software engineer, a developer earning about $120,000 a year, that totals approximately $60 to $90,000 in in cost when it comes to trying to find that individual's replacement. And if I'm not mistaken, that doesn't even include training cost as well. And last but not least, as we looked over in our last slide, wasted developer cost. If we're spending the majority of our time, if we're allocating a good amount of our time, which is roughly 42% for the average developer, on not only having to deal with bad code, but the effects of it, that's wasted, developer cost as well. Jumping over to bad pipelines, right? Well, long pipeline runtime equals higher server costs. And I've received some bills before, and it was not pretty. Long pipeline runtimes also means developer idle time cost, right? So a developer spent waiting for something to build, and again, having, again, as I stated before, something that could build in, like, let's say 15 to 30 minutes ends up taking 45 minutes to an hour. That's idle time. That's Twitter time. That's hopefully they're working on a feature, but I've seen a lot of likes and retweets by developers. And another thing as well, difficult rollbacks equals money lost. Now, when I first started off as an engineer, I was tasked by the CEO of this lovely startup that I used to work for to streamline the way we deploy things. Now, what we had was an e-commerce website, and I was like, hey, awesome, I can do that. What I didn't take into account is if things go south, if something were to go south, or offer to deploy a bug into production. And it was Friday night. Thank goodness it was a Friday night. And I decided to deploy to production, and things broke and things got really messy. And I spent about a good 3 to 4 hours trying to solve specifically what the mess I made. And so that was about roughly 3 to 4 hours of downtime. Now, if you were to think about that, I'm glad it was during the off-peak hours of of our platform, because if it was during the the high peak hours and I decided to deploy, that would be a lot of money lost. And last but not least, the end user experience, right? So how does bad code affect the end user experience? Well, first off, poor application performance. Another one being inconsistent user experience, right? So having the lack of consistency of being able to boot up the app, or even being able to use certain features. And it reduces feature reliability. So as you start building out and making changes, let's say to certain features, if your code isn't well maintained, the reliability of the features that you may be working with or editing at any sort of point, the reliability of it just substantially decreases, which in return reduces overall product quality. Now, for bad pipelines, right? Oh, if you have a pipeline that's not really well structured, pipelines themselves can be very difficult to operate and maintain as you start scaling out and, as I said, deploying more and more things. Also, it lengthens the feedback loop. So from when an end user reports a bug to the developer fixing it to then having that deployed as well, that feedback loop itself, hotfixes will take longer to reach the end user. And it prevents the developer from adopting new developer tools. Now, what do I mean by that, right? We can look at things from, as I said before, integration tests. But if a developer says, hey, I found this new, and behold, a new tool that'll help us out in our deployments, right? If you have a pipeline that is very difficult to operate and maintain or whatnot, it'll prevent developers from being able to adopt, try out, or even experiment with new tooling that may improve the overall integrity of the product or application. So now that we've talked about all of that, it's about time we go ahead and get to the last, and in my opinion, my most favorite part: actions to transform the current state of your application that may have bad code or a bad, or I like to say inefficient pipeline. Now, looking at actions, what's the very first thing we should do? Well, the first thing that you need to do is assess the current state of your code base and or pipeline. All right. Now, not both. Take a step back, choose one. It's all right. Everything will come in due time. And for example, if we're looking at reviewing the, assessing or just reviewing the current code base, it's really, while we're doing that, it's really easy to label things as bad code, right? Which brings me to my second point. Ask questions. Understand why things were done and implemented the way they were. Because again, it's very easy to just label something as like, oh, this is bad. Oh, this is terrible. Oh, this isn't good, right? Understand the reasoning and the history behind a lot of the changes that have taken place and are currently taking place. And that right there will paint a better picture in regards to and assess the current situation and the current health and state of the code base that you're in. And next up, before we even start implementing, saying, hey, all right, I've asked all my questions. I want to go ahead and do some major refactor, major change. Not just yet. The second thing I recommend you do is gain support and establish credibility. Now, a way to do that is to start with quick wins. Now, if we take a look over here for that we have on this lovely, lovely 4-quadrant chart that we have here, right? This graph on the very far left, what we see here is like, this is our x-axis is implementation. So from the very far left, the level of difficulty tends to be on the lower end to implement. And then as we go further to the right, things become substantially more difficult. Now, I want to keep this in mind. As I said, as we look at this is my own opinionated, graph on the way I think, things are due to my personal experience. Things may be completely different for you. And on the y-axis, we look from the very lower part, the level of difficulty seems to be on the lower side in regards to gaining support, right? And then the difficulty for gaining support will essentially be on the higher and higher end, right? So, on the upper part of the y-axis. And what I mean by start with quick wins is look at something that's, on the lower difficulty end of things to implement, but also, less resistance as well too. And the one thing I always start with when it comes to, even just as a developer, is I start with Prettier.js and ESLint, but more specifically Prettier.js. And the way I pitch that is I go up to the developers and let's say, for example, I'm in a code base, which I have been before, where tabs are all over the place. One file has 4 tabs, every time you tab, there's like 4 spaces. In another file, you have, every time you tab, there's 2 spaces. So there's a lack of, uniformity in the sense of formatting. And I'll go to the developers and say, hey, I want to go ahead and, I'd love to take a couple days and honestly have y'all worry less about having to deal with formatting and have a level of consistency in regards to formatting in our application. It'll only take me a couple days. And once I'm done doing that, what I'd love to do is set you all up with this. And so that every single time y'all just decide to save, you don't have to worry about formatting. It'll auto format for you. And developers love it. All right. I remember the first time I started with Prettier as well too. And that was the best thing in the world. And so having those small wins, add up over time. And as you start increasing, as support becomes substantially more difficult for a lot of larger changes, or things become a lot more difficult to implement, it becomes a lot harder to get those quick wins. But in return, what I recommend you do is, as you start going to those things that may become a lot more harder to implement and even gain support, now your dev team could be all on board and say, hey, yes, we need to adopt a style guide. Oh, we need to do testing. Oh, we need to go ahead and, let's focus more on improving our pipeline, right? But business may not feel the same exact way. They may want features and for you to focus on fixing bugs, right? And what I always try to do for a lot of those things that may have a lot more resistance brings me to my second point. I always try to show the potential financial savings, behind those things. So having saying, hey, you know what, if we improve our overall, like the overall build time of our pipeline, it'll save us $100,000 annually. That speaks a lot more, not only just to the developers, but also to business as well, to justify, uh, to justify time being allocated and even resources being allocated to that specific cause. So that right there, overall will help you in regards to, gaining support and establish credibility. And once you have that, last but not least, you have step 3: implement the proper tools throughout your development process. And with those 3 steps right there, that'll be able to, at least, you'll be able to put some things into action and move forward with improving the overall well-being and the current state of not only your code base, but and or pipelines as well. Now, here's my works cited. I hope you all enjoyed my talk. Thank you so much for, listening and coming to this conference. I hope you all are having a great time. I am, and I can't wait to hear all the other talks. I hope you all have a great day or evening, and let's connect on Twitter. Okay, follow. Let's connect. Right. Add me on Twitter, or follow me on Twitter. Follow me on GitHub, or even connect with me on LinkedIn. All right. I'd love to hear everyone's thoughts and experiences. So I hope you all have a great day, and hope to see you all again. Thank you.